Now, just as a refresher, as we're starting to talk about statistics, it's helpful to bring to mind all of those vocabulary terms related to statistics. First of all, the one that you should be most familiar with are the measures of central tendency, which are the mean, median, mode, and the quartiles. The mean is basically just the average of all the data. The median is the middle number, which is the value that falls directly in the center with 50% of the data below and 50% of the data above. The mode is the most common or most frequent data value, or the one that occurs the most. And the quartiles separate the data into 4 equal parts. Just like the median occurs in the middle, it splits the data into 2 equal parts. The quartiles are 2 additional numbers which break it into 4 equal parts. Besides measures of central tendency, which is how clustered the data is towards the middle, we also have measures of dispersion, which is how spread out the data is around that middle. The range is the difference between the highest and lowest value, which basically shows us how many numbers fall between the most extreme values of a data set. The interquartile range is very similar, except it's rather than between the max and the min, it's between the first and third quartile. And it happens to also be where the center 50% of the data is clustered. The standard deviation is a measure of how widespread an observation is to be from the mean, or it's basically the distance a given observation falls from the mean. The variance is the square of the standard deviation. And an outlier is a data value which falls outside the general pattern of the data, and we have a mathematical process for determining if a given value is an outlier. So let's put some of this into practice in the context of an example. Find the measures of central tendency for the following data set, as well as the measures of dispersion. So before we can do that, we're going to have to enter this data set into a calculator to calculate all of these measures for us. So with my calculator in hand, I'm going to need to enter this entire set of data values into a list. So to do that, I'm going to hit the Stat button, which is located right here. Once that comes up, I'm going to have a series of options. I'm going to select Edit by pressing 1. And that will allow me to enter these values into a list. Now, I've already entered these values to save time. And basically, exactly as you see them, you type them into the list one after the other. Then to calculate these measures of central tendency, I'm going to hit the Stat button again. And notice there is a Calc option in the second window. To get to it, I'm going to press the over arrow. And these are all called one variable statistics. So again, I'm going to press option 1 to pull up one variable statistics. Now, since I don't have a frequency list, I'm just going to go ahead and hit enter, and it will calculate the one variable statistics for the values I've entered. So the mean, which is represented by this X with a bar over top, is 80.4. And I have a series of other statistics calculated here. The main one I'm going to get from this first window is the standard deviation, which is abbreviated by this capital S. So that's 11.1. So that's my standard deviation. And then to get most of my other statistics, I'm going to have to scroll down by pressing this down button. I'll have the minimum, which is 58. I'll have the first quartile, which is 73.5. I'll have the median, which is 82. The third quartile, which is 88. And the maximum, which is 98. Now you might ask yourself, why do I go from quartile 1 to quartile 3? What happened to quartile 2? Well, quarter 2 is actually the median. It's just has a specific name. Now, for some other values, this calculator falls short, so I'm going to get it out of my way. To find the mode, I need to simply look at my data set. The mode, recall, is the most common value. So as I move through this data set, I see that 80 so far is the only value which occurs more than once. And as I continue to go through, I also see that 88 occurs more than once. So since these two values occur more than any other, they are the mode. 80 and 88 are both the mode. This data set is called bimodal because it has two modes. Now to find the interquartile range, I simply take the difference of my quarter 3 and quarter 2, so 88 minus 73.5, which would give me 14.5. is my interquartile range, the difference between my quartiles. If I wanted the range of the entire data set, I'd take 98 minus 58, which would give me 40. Okay. Now, another way we can represent this data, once we've calculated these statistics, is with what's called a box plot. Now, all a box plot is a graphical representation of the distribution of the data. To create a box plot, I'm going to note what my minimum value is and what my maximum value is. So all of these numbers range somewhere between 58 and 98. So I'm going to make a scale between 50 and 100, which is a large enough scale that it would encapsulate all of my data values. And I'm going to break up that scale into even marks. So I'll go 60, 70, 80, 90, and 100. Now I'm going to graphically represent my data. To do that, I'm going to first plot my minimum, which is 58, and I'm going to do that over this number line, which would be here at 58. I'm also going to plot my maximum, which would be 98, which would be approximately here on my number line. I'm going to plot my median value, which is 82, which would be roughly here. And I'm going to plot my two quartiles, 73.5, which would be approximately here, and 88, which would be approximately here. I'll connect those quartiles with the box, and I'll connect my max and min with what's called the whiskers, hence the term box and whisker plot. And that gives me a visual representation of how spread out my data is. These 5 values also make up what's called the 5 statistical symmetry of a data set. Now, this is just one graphical representation of a data distribution. Another type is called the normal distribution, which can be modeled by the normal curve. Now, because all normal distributions share the exact same characteristics, we can standardize a given distribution knowing that it's normal and relate it to the normal curve by using z-scores. And the formula for a z-score is basically just a given observation minus the mean divided by the standard deviation. So here's an example of how we can use this. On a standardized test, test scores are normally distributed. You can only use this information when a data set is known to be normally distributed, which has a mean, which again represents that x bar, and a standard deviation of 6. So that's the standard deviation. So what's the z-score of 48? Well, z is the value of an observation, which in this case is 48, minus the mean, which we know to be 60, divided by the standard deviation, which in this case is 6. Well, 48 minus 60, negative 12, divided by 6 is just negative 2. So that's the z-score. Now it asks what percent of students scored below 48. Well, using the z-score, I could either go to the normal graph to see where the z-score of 2 is and add up the percents which are less than that value, or we can use our calculator, which has all this information stored in it. Anytime you want to know a value of a z-score at or below a particular value, you first need to calculate its z-score. So the z-score for 48 we found in part A was negative 2. I'm going to plug it into a function in the calculator called the Normalcdf, which stands for Cumulative Distribution Function. And what this function does is it adds up all of the percentages of values between two given z-scores. Now we want everything below 48, which means that we're going to go up to 48, which will be my larger z-score. So now, if I want to add everything below it, I technically want to go forever, but our calculator can't add things up forever. So we're going to plug in a z-score that's so far outside the normal distribution of data that it basically is equal to adding up forever. And a value which is large enough for us would be negative 10. So I'm going to sum up everything from -10 to -2. I'm going to clear whatever was on my screen. And to access this Normalcdf function, it is a distribution, which if you notice is right above the variables button. So to access it, I hit the second key, and then the distribution, and the Normalcdf is the second one down. So I'm going to press the down key to highlight CDF, and hit enter. Then I will type in -10, comma, -2, close parentheses, and hit enter. And it gives me that the Normalcdf for that value is 0.02275, which is equal to 2.28%. The follow-up question in Part C is that if 2,000 students took the test, how many would you expect to score below 48? Well, from Part B, we know that 2.28% of them would score at or below 48. Well, 2.28% of my 2,000 students mathematically can be represented by the number 0.0228 times 2,000, because of is a keyword for multiplication in math. Well, I actually have that entire value unrounded still in my calculator, so I'm just going to take that value and multiply by 2,000 so that I have no rounding error, and I get 45.5. Well, since I can't have half a student, I'm just going to say that it's somewhere between 45 or 46 students. So somewhere between 45 and 46 students would score at or below 48, again, because you cannot have half a student. Now, sometimes we'll have to do this process in reverse, where we know the percent values and we want to know what the z-score is. To do that, we're going to use a function called the inverse normal. Now, what the inverse normal will do is it takes this number value, which as a percent is 84%, but as a number is 0.84, and gives me back the z-score associated with that percentile rank. To access it, it is also in the distributions key menu. So I'm going to hit the distributions key and do inverse normal of 0.84, enter, and I get 0.9944. So my z-score is equal to 0.9944. And it was the question was asking of the data, what score on this test or this exam would give me 84% of the students at or below. Well, remember I have this z-score formula, and I have the mean and standard deviation. I'm trying to find the score on the test, or the x value, associated with that percentile rank. So I'm going to fill in all of these numbers. The z-score, this value is 0.9944, which is equal to my observation x minus the mean, which we know to be 60, over the standard deviation, which was given to be 6. So what I'm going to need to do is multiply both sides by 6. Well, fortunately, I still have this number, 0.9944, stored in my calculator. So I'm just going to multiply it by 6. I get 5.966. So that's 5.966 is equal to x minus 60. Then to solve for x, I'm just going to add 60 to both sides. And again, I have this entire number unrounded, still stored in my calculator. So I'm going to add 60 to that. And I get 65.966. If I was to round that to either the 1,000th, 10th, or 100th, all of them would round up to a score of 66. So you would need to get a score of 66 on the test to do better than 84% of your classmates.